Hi guys, welcome back to another video. So I was finally able to build a 2-meter tape measure Yagi. I know this has been covered on numerous YouTube channels before, and there's loads of details on the internet as well. But I've never built one before. Plus I got the 3D printer, so I was able to print off the element holders. And also the Radio Club have got fox hunt transmitters. They've done events in the past, but they haven't done one for quite a while. So I thought it would be a good activity to revisit. Plus we've got a few new members. I don't think they've got tape measure Yagis, so we can actually build them as a club project. And maybe we can contact other local clubs in the area and we can ask them if they want to do a fox hunt event. Be a good social gathering, to be honest. The initial details I followed for the tape measure Yagi was on instructables. And when I checked it out on the NanoVNA, it come in more at 147 megahertz. So I want to bring it more into maybe 145. So I did a bit of research online, come across Peter Parker's YouTube channel. He built a tape measure Yagi. He followed Joe WB2HOL's details, and he shared those dimensions on the channel. As I cut mine initially short, and like Peter did, he cut his short. What he'd done was basically sanded it away and then added a bit of wire to extend the elements. I also had to do it for the reflector as well. So I've done that. Now that I know it's at 146, in an old book of mine, I've written down equations, and one of them is the current frequency divided by the target frequency times it by the length. So one leg of the dipole, for argument's sake, and then you can get a new measurement. So I can use 146 divided by 145 times it by the length of the element, and then I can get to 145. So I can basically adjust the bit of wire to suit and just extend it out. And once I've finally got it to where I want it to be, I can take that new measurement and then make proper full elements out of the tape measure and not have these bits here, because I think over a period of time that will break. I know you could resolder a new bit on, but it's a handy way of just doing some testing to get it where you need it to be. With the 3D printed parts, I've done it in pink again because I'm just using the filament that I got given with my printer. So I don't mind doing prototypes in this. But you can see it goes through the element holder, the coax, and that runs down the boom, which is quite handy. I found when I was touching the coax, it would alter the match on the NanoVNA. So I put in 9 turns of the coax in, and also the dimensions that Peter showed for his one, there was a gap of 42 millimeters. I just put the tape measure on and I just lined it up with the hole, the edge of the hole. So there's a bit of a gap in the middle. I initially connected the coax right on the end, same with the hairpin, and I found that I needed to bring that in and solder it a little bit closer, and that brought in the match better. So that works out pretty well now. It's quite good. Like I say, what I'll do now is do the equation, extend all of the elements where I need to, and that will get me better at 145, because I want to use the antenna not only for the fox hunts, but I want to use it going out portable, put it in the car, and if I ever need an antenna quick and easy, then that could be maybe a choice. Obviously, due to the weather, if it's windy, these will flex around quite a bit, so probably not ideal in windy conditions, but it's a bit of a fun project. I think it'll be good for the club. We've got quite a few newly licensees that haven't done a lot, so this will be a good club project as well. I'll put up a screenshot now of the match currently, and then maybe in a short later on, I'll show a screenshot and details of the length that I've got to with my tape measure Yagi at 145 megahertz. Hopefully you found that video useful, and we'll catch you on the next one. 7-3.